In this video will I be showing you guys how you can design and 3D print your own RC car spare parts. I've been using 3D printed spare parts on my on-road sedans for a little while now, so I know how they should be designed to make them work. I've found that it's very easy to make working parts for the car chassis. That's parts that don't move very much, like the parts in the steering, suspension arms, things like that. That is easy. The hard part comes when you try to make parts for the car's drivetrain. The thing is, these parts will be moving very fast and it really increases the amount of stress that's put on the part. While designing these spare parts, I've made a bunch of prototypes and they really taught me what to look out for when designing these parts. The orientation you decide to print your part in plays the biggest role in the strength of your RC spare part. That's because it's the adhesion between the layers that's the weakest part in a 3D print. This first part has been printed with the layers vertically going down the part, and as you can see, I'm able to break it pretty easily. Keep in mind that this has only been printed at around 20% infill. The reason this breaks so easily is because the cross section between the layers is very small and thereby decreasing the layer adhesion. This next prototype has been printed laying flat. This has increased the total layer adhesion by a lot and it has made the part much tougher. I'm still able to break it, but it was much harder to do. This part has been printed laying flat, and that means it's super strong in two directions. And that is exactly what you want from this part. Although there is one issue. Because it was printed laying flat, the holes near the end are suffering. The side walls are only held together by the layer adhesion, which isn't very strong. The solution is to print the part at an angle. That way you increase the strength near the hole in the end by compromising the strength in other areas. This will work because before the part was really overkill in one direction, but it was very weak in other directions. This way we even out the strength. Now it's time to start designing our own parts. I pulled off the rear suspension arm from my on-road sedan, and this is the part that we'll be designing and printing today. Start off by using a caliper to gather all the critical measurements. These measurements will be my guidelines when I go into Fusion 360 to model this part. I start off by sketching a rectangle with the outer dimensions. Then I use lines to cut into that rectangle and that way shaping the part. I can now extrude the part upwards, giving it thickness. I now create another sketch from the side that I use to cut out the front profile. I'm now cutting out the holes, and I'm intentionally over-dimensioning them by about 0.4 millimeters because I know my printer will print the holes about 0.4 millimeters smaller. Now a bit of chamfer to make it the best. This is what the final part looks like and is now ready to be printed. I'll now import the STL model into Revit Host. I put the model at an angle to increase the strength around the holes. I then slice it using 0.2mm layer height. Here you see the suspension arm right off the printer. and after a bit of cleanup, this is what it looked like. The quality of the print was absolutely perfect, and it is extremely robust. There's no way this is going to break, and this was even printed in PLA. If you print it in ABS, then it will be much more tough because it won't snap like PLA does. Here I'm trying my absolute best to break the part, but it's just holding up. I was able to mount the part on the car without having to do any trimming at all. It just fit perfectly, and this is going to work great as a replacement for the original part. It may not be 100% as strong as the original, but since these replacement parts only cost around, I don't know, a few cents, then I would much rather use these than having to buy expensive replacement parts. Thank you so much for watching this video.